Heat pumps are outselling gas furnaces these days in the US. That's our Techstination. I'm Fred Fishkin. Joining us from Bosch is Roman Wechsler, lead engineer, and product manager, Jakub Kytka.
Hi, Fred.
Hi,
Thanks
Fred.
for having us.
Oh, great to see you. Now, Bosch is one of the companies offering some really innovative options when it comes to heat pump technology. I don't know which one of you wants to go first, but give us a bit of an overview here.
So basically, our main focus here at Bosch, located in Germany, we are mostly focused on the European market. We do have additional business unit which is dealing with the US market and outside Europe more than we do. But basically, our main focus here in Germany is focused on residential and light commercial applications. And mainly speaking, it's a technology air to water, so the heat pumps which use the air as a source, and then basically that medium where the energy is transferred to the house or to smaller building is then the water.
Well, describe for us how that works. What does that mean?
Yeah. So in general, what a heat pump does is it draws energy from the environment. In our case, the ambient air. This energy is free of charge and is then upgraded to temperatures where it can be used for heating purposes. For this upgrade to the usable temperature level, electrical energy is needed. This is the energy that the end customer, has to pay for. And usually the ratio of the overall heating energy that you get out of the system compared to the electrical energy that you put in is between 3.5 and 5, depending on the heating system and the operating conditions, which means you get between 3.5 and 5 times more energy out of the appliance than you put in terms of electrical energy and for which you pay on your bill.
Interesting. And there are different types of heat pump systems. And you mentioned air, water, but there are others too. And it can be a little confusing for consumers, I think, because there are different form factors too. You want to get into that a little bit for us?
The selection of the technology of the heat pump, as we call it, so if it's a liquid water or air water or even air solution, is purely dependent on what's the surrounding or what's the, let's say, as we call it, use case. So it's very purely use case driven solution. Some house has a big property and therefore maybe the option of liquid water with some ground source collector could be a good option. In some areas, the drilling itself to make basically the borehole is almost impossible. It could be due to the material which is then the consist under the house, but also due to the legislation. So we have in Europe many countries which are very strict about who can drill and who cannot drill. And last but not least, it's also quite costly driven. So in some markets, the drilling is relatively affordable. In other markets, the drilling can cost even 10 times higher than in the neighbor's country. But what we could see or say it's that if we have, let's say, climate where we don't see that often sub-zero temperatures, meaning in Celsius, the main go-to solution is air water, which is not just affordable, but also very easy to install. You don't need any extensive planning. It can be installed by 2 persons. You don't need to have any drilling company involved. And therefore, for this type of markets, which we are currently facing, to replace the gas for the heat pump, it's, I would say, the most suitable one because you do not need to interfere with already existing setup in your house. So it's kind of plug and play in easy words, so to speak.
You've announced some new heat pumps using the natural refrigerant, R290. Tell us about the significance of that.
So R290 is a natural refrigerant. It's propane, basically. The properties of this refrigerant from a thermodynamic point of view are excellent in terms of heat pump technology. So you reach high efficiencies, you reach high water flow temperatures, which is especially relevant if you use it in retrofit use cases. And what's also very important is that it's a low GWP refrigerant, which means refrigerant with a low global warming potential. The traditionally used refrigerants such as R410A have a very high global warming potential. I think it's in the thousands, which means 1 kilogram of R410A, if it escapes into the atmosphere, is as bad as a few thousand kilograms of CO2. And in case of propane, the GWP, the global warming potential, is only 3, which is basically nothing because usually not big amounts escape into the atmosphere. So in a nutshell, from a thermodynamic point of view, excellent refrigerant with a low GWP, and therefore also future safe in terms of already ongoing and also in the future coming legislative changes. Yeah.
What are some of the key benefits to switching to heat pump technology? What should people know?
Yeah, so I would say one benefit is, of course, to follow the path of decarbonization. So especially in Europe, the most of the houses are heated by fossil fuels. It's either natural gas or it can be also oil. And therefore, many countries, mostly driven by European Union, are basically following this path to decarbonize Europe. They are also supporting that with subsidies. So there are several subsidy schemes rolled out across Europe, where you, as an end customer, if you decide to do the switch, meaning replace your gas or oil boiler for renewable energy source, electrified renewable energy source, you get a certain amount of money from the government, and it can actually be even quite significant portion which can be covered by government. So I would say it's a mixture of ecological aspect, as Roman also mentioned, be kind of future-proof. We all know the situation at the moment. Europe is strongly dependent on the gas, which is coming from Russia, but also to have this kind of saving in mind, because as Roman explained before, you are basically paying for 1 kilowatt of energy while you are getting 3 kilowatt and more of the heat out of it. So I think this aspect of getting something for free, it's very resonate in many customers.
And especially for people who have maybe solar panels, it can really be economical, right?
Exactly, yeah. In that aspect, we also have quite broad portfolio. So we are also offering inverter and battery storage, and on top of that we have energy management, which kind of overseeing the whole system and help you with being very energy efficient. So if you have solars and you get a peak, that means that this energy management can overrule the your wish or your demand, and maybe store the energy into the tank, which you can then use for taking shower or heating later on when the sun is not that strong, for example. So yeah, we are working in many aspects to make the heat pumps more attractive for our customers.
So what advantages does Bosch have over, we've got lots of competition in the space, companies that are into the heat pump technology. What advantages do you feel you have here?
I mean, one of the main advantages that we aimed for, or the main USPs that we aimed for in the current development and that we also achieved, was to be best in class in terms of sound. So this is especially important in the Middle European market, in new built areas where you have houses very close to each other. And there's a quite strict legislation in Germany, for example, that restricts the location where you are allowed to install a heat pump. depending on the sound it emits and depending to the distance to the neighbor. And I think we are able to, if I'm not mistaken, to install our heat pump within a 2-meter distance from the neighboring ground, which is better than any of the competitors that I'm aware of. So this is definitely one of our USPs, but I think Jakub has some more.
You took the most significant one, but of course, to also add, I would say if we look at the competition portfolio or offer in Europe, we see that the heat pumps is basically in everyone's portfolio these days. What we can offer is we made our products completely in Europe. So they are either made in Sweden, Germany, or in Portugal. And we, of course, also see very strong customer base, which is in our case coming mostly from the traditional business, which is gas. And we are trying to work hard to basically transition these customers into buying and selling, of course, heat pumps in the future. So I would say we are very close with our customers. We try to understand their needs and to also help them in this transition, because the demography of our customers is, let's say, in the age where no one wants to accept or is not really much willing to do something different than he did last 20 or 30 years. So we are really trying to develop the heat pumps in the way that they are easy to understand, that they are easy to install, and also easy to operate for our end customers.
Terrific. And of course, the name says heat pump, but these things also cool as well, don't they?
Yes.
Yeah, they do. Yeah, I mean, this is a function that is basically available in all of the air-water heat pumps. So yeah, you can use it for cooling, as you already mentioned. Usually this is done in combination with underfloor heating, but you can also do it in combination with fan coils, for example. And yeah, I think it's a really nice add-on feature to the main function of heating.
And for homes that have ducts in them that have used like a gas furnace or in the past, is it easy to retrofit this technology?
I would say it's easier with the R290 or propane based heat pump than it's with R410. As Roman mentioned, I think at the beginning, the propane also enables us to reach a bit higher flow temperatures. So regarding the retrofit aspect, let's say it's less invasive. So you do not need to do that much adjustments on your house than you would need to do with, let's say, a traditional refrigerant. But we always emphasize that the heat pump works the best and most efficient when the difference between the temperature on the let's say input is as close to the temperature as on the output. So lower the temperature is operated, meaning flow temperature wise, the more efficient the heat pump is. And then of course it's always up to our customer to decide how big the investment he wants to make in order to benefit from that in the future.
Roman, did you want to add to that?
Yeah, maybe an additional remark regarding air-based heating systems. I think this, if I understood you correctly, this was what you were referring to. So what we also offer is a ventilation-based heating solution, where you have normal ventilation-based heating in combination with a heat pump, and then you can use the heat pump to heat up the air, or also cool it down, for instance, by using environmental heat. So this combination exists as a solution by Bosch and is available.
Very interesting. Where is the best place for people to go for more information?
Our webpage, of course. So yeah, we have a, I would say, very complex or informative web page. We also do offer some kind of dimensioning tools where you as an end customer or even as a semi-professional, you can with our help basically, which we have based on many measurements and many technical data which we have in the backbone of the system, you can give us a few information about your house, what do you currently have, and what would you like to achieve with our heat pump, and then we give you a recommendation which product would be the most suitable according the tool. But of course, as every system is different, and we want to have everyone wants a very well working product and long working product, we always recommend to contact the professional, which in this case is your installer, which is dealing with your heating system, which is then the one who is giving you the best suitable or the most suitable product.
And of course, the climate and environmental concerns are very important, but a lot of people are motivated by how much money they might be able to save here. How significant is that?
Yeah. So maybe I can answer from a technical point of view, and Jakub could go in more detail in terms of incentives and so on. So as I mentioned in the beginning, the efficiency of heat pumps is between 3.5 and 5 over an entire year. That means you have to pay 1 kilowatt hour of electrical energy for 5 kilowatt hours of heating energy. And if you compare this to a gas furnace, for example, I mean, it really depends a lot on the ratio of electrical energy compared to gas energy. So this is, I think, as a rule of thumb, we could say a ratio of 3 or more would be beneficial, or less would be beneficial. 3 to 4 or less, and
yeah. I have not much to add. It's also very much dependent on your use case. So what we are currently having, how your house looks like, what are the running conditions, and so on. So we cannot really put any price how much you can save in absolute figures. But of course, there are calculations, and we can also support with that, and our customers can get this advice to look at the specific case always and give some kind of calculation or estimation.
Finally, we mentioned at the beginning how fast this is having an impact in the US market. Tell us what's going on there in Germany and Europe when it comes to this technology.
So yeah, in general, heat pumps is a thing. Yeah, at the moment, I would say 95% of new built houses are equipped with the heat pump. So this is the first choice of heating device. We also see very significant shift in the existing buildings, so as we call it, a renovation market, where people are currently mostly motivated by the government incentives. So the shifts towards electrification and in our case, heat pumps is massive. We see markets which has a 200+% growth in heat pumps compared to last year. So as you also know, the situation at the moment in every industry regarding the supply is challenging, but I think we are on the good track now to deliver to our customers the product which they all are wanting, basically.
Well, congratulations on the innovations there and the success that you've had. Jakub and Roman, thank you for spending time with us.
Thank you, Fred.
thank you for having us.